Howdy, today on Flippin Science we're going to be looking at primary, secondary and tertiary alcohols. So what do we mean by that? So a primary alcohol, the hydroxyl group is attached to a carbon that's attached to one other carbon, or in the case of methanol, a hydrogen. So when we're looking at primary, we're talking about how many carbons the carbon that's attached to the hydroxyl group is attached to. And that sounds confusing, but what you do is you look at the hydroxyl group, you look at the carbon, and you see what it is attached to. If it's attached to another carbon, that makes it primary. If it's attached to 2 carbons, that would make it secondary. If it's attached to 3 carbons, that makes it tertiary. So, primary alcohol. So, an example of a primary alcohol is this one here. So, we've got 1, 2, 3, 4 carbons. So, methyl ethyl propylbutane, butanol, and butan-1-ol, because the hydroxyl group is on carbon 1. So, that's a primary alcohol. The hydroxyl group here is attached to a carbon that's attached to 1 carbon, so that makes it primary. The secondary alcohol, that's where your hydroxyl group is attached to a carbon that's attached to 2 carbons. So here's my hydroxyl group making an alcohol. Here's the carbon that the hydroxyl group is attached to, and that's attached to 2 carbons, and a hydrogen as well in this case. So, a good example of a secondary alcohol is this one here. So this is butanol like we had before, but now it's butan-2-ol because the hydroxyl group is on carbon 2. So the hydroxyl group is attached to a carbon that's attached to 2 carbons. So that makes it a secondary alcohol. So in a tertiary alcohol, the hydroxyl group is attached to a carbon that's attached to 3 carbons. So here we've got 3 carbon chains, R1, R2, R3. This is the hydroxyl group that makes it an alcohol. It's attached to a carbon that itself is attached to 3 carbons. So 1, 2, 3. So an example of a tertiary alcohol is this one here. So 1, 2, 3, 4. So the longest chain though is a 3. So this is 2-methyl propan-2-ol, or methyl propan-2-ol. There's only one place that can go. So 2-methyl propan-2-ol. So if we look at the hydroxyl group, it's attached to a carbon that is attached to 3 carbons. 1, 2, 3. So that's a tertiary alcohol. Now we're going to look at how these things react, specifically what happens when you oxidize them. If you oxidize a primary alcohol, the alcohol goes to an aldehyde, and then if you oxidize that further, it becomes a carboxylic acid. So primary alcohol, the alcohol goes to aldehyde, aldehyde goes to carboxylic acid. If we just want the aldehyde, we'd have to distill that out as soon as it forms. But if we want to go all the way through a carboxylic acid, we just keep on oxidizing. For a secondary alcohol, the secondary alcohol goes to a ketone. So that has a C-double-bond-O group in it. Tertiary alcohols, they don't oxidize at all. So let's look at some examples of that oxidation process. So when you oxidize a primary alcohol, you go from primary alcohol to aldehyde to carboxylic acid. So if we have a look here, we've got methyl ethyl propan butan-1-ol. Butan-1-ol, primary alcohol, so the hydroxyl group is attached to a carbon. That carbon is attached to 1 carbon. That goes through to butanal, so methyl ethyl propan butane. So butane is the parent carbon chain. This is an aldehyde group here now, and then that oxidizes further through to butanoic acid. So methyl ethyl propylbutane, and this is a carboxylic acid group down here. If we have a look at what that looks like on the model, we'll start with our butan-1-ol, so methyl ethyl propylbutan-1-ol. When we oxidize that, it goes to butanal. So that's this one here, so methyl ethyl propylbutane. We've got our C-double-bond-O group here, and then our H at the end. So that makes it an aldehyde. So then if we oxidize that further, we get butanoic acid. So that's this one here. So we've got, normally this is how we would represent it. So methyl ethyl propylbutane, C-double-bond-O, OH. So that's butanoic acid. Now we'll look at what happens when you oxidize a secondary alcohol. So here's our secondary alcohol, so methyl ethyl propan butane, butan-2-ol. So this is butan-2-ol, because here's our hydroxyl group, it's on carbon 2. When we oxidize that, we make a ketone. So this would be butan-one. We don't need to say butan-2-one because there's only one place that the ketone group can go on this one. So on carbon 2, we've got our ketone group. So we oxidize our secondary alcohol and it goes to a ketone. So what does that look like? If we've got our secondary alcohol here, so butane-2-ol, so methyl ethyl propane butane-2-ol. Then if we oxidize that, it goes to butanone. So here's our ketone group, our C double bond O group on carbon 2, so that's butanone. When we look at tertiary alcohols can't oxidize at all. So here's our tertiary alcohol, so methyl propane 2-ol, so 2-methyl propane 2-ol. So if we have a look at it, there's no bond we can make with this carbon that goes up here. We can't make an additional bond. We can't get rid of a hydrogen to make another bond to the oxygen in the oxidation process. So tertiary alcohols don't oxidize. So today we looked at primary, secondary, tertiary alcohols and what happens when you oxidize them. That's it for Flippin Science today. See ya.